Sketch the rational function y equals x plus 3 over x minus 3. So in this case, the degree of the numerator and the denominator is the same. Now we don't need to go as far as doing division here. We could do the following. We could write the top as x minus 3 plus 6 over x minus 3, and then we can split the fraction. So we have x minus 3 over x minus 3 plus 6 over x minus 3, which is 1 plus 6 over x minus 3. Now, the part that isn't a fraction tells us that y equals 1 is a horizontal asymptote. So it wasn't oblique, and in fact we get oblique ones when the degree of the top is greater than the degree of the bottom. Otherwise we'll get a horizontal asymptote, which isn't just the x-axis as it was when we had the situation with p of x over q of x, but the p of x having a degree less than q of x. So vertical asymptote would be x equals 3. So we've got that, and we can probably start putting things onto a sketch at this stage. There might be some other things that we want to discern before we actually make an attempt at the sketch. So x equals 3 is a vertical asymptote, and y equals 1 is the horizontal asymptote. Now if we go back there, we can see that there would be an x-intercept at negative 3, because negative 3 would make the top 0, and then y would be 0. So at negative 3 there, we're going to have an x-intercept, and that is the only one. What about when x is 0? When x is 0, let's do it down here. X equals 0 means that y would be 3 over negative 3, which is negative 1, which gives us the y-intercept there at negative 1. Now, there is only one thing that this can really do, because it's got to go out there, through those 2 points, and then down the asymptote. And then there's only really one thing it can do up here. So what we actually have there is a rectangular hyperbola, and you should be able to spot that because you should know that's a rectangular hyperbola, and then that is just a transformation of that. So no need to differentiate here, although you could have done to see if there was a turning point. You could also check regions, so you could say, okay, what happens to the left of negative 3, and what happens to the right of 3. And so if we go to the left of negative 3, then going to the original function, we would have a negative divided by a negative. That's why it's positive. Once you go between negative 3 and 3, what we would have then is a positive divided by a negative, and so that would be negative. And then once you're to the right of 3, they're both positive, so that's positive, and you can see that all fits in. That's positive up there, and then between the asymptote and the intercept it's negative, it's below the axis, and then it becomes positive again over there.